Hello and welcome to LFI Educates. In this video, first we'll learn about addition of vectors analytically. Analytically, when we say, then we know that vector has both magnitude as well as direction. So how to calculate the magnitude and direction when you do addition of vectors that you are going to learn. Here I am drawing the diagram that you can see here. The triangle of addition, you already know the diagram. Suppose this is vector A, that will be represented by OP, and this is vector B is represented by PQ, suppose. Then the closing side, that is OQ, will give you the resultant in the opposite order. That I am writing it as R equal to A plus B vector. This is geometrically that you know already. Now, what is the magnitude of R and what is the direction of R? Magnitude of R means the value of the resultant vector R, and the direction means at what angle this resultant is making with the vector A. Suppose say this is phi. This will have to calculate it. The direction you will get it from this value phi. Now, to find out the magnitude, you have to construct here. You will drop one perpendicular line with OP produced. This angle will be 90 degree. Let it be M. And the angle between the vector, this vector is pointing this side, right side, and this vector is pointing up this side. So the angle between them, angle between the vector will be here, theta. This is the angle between the two vectors. So you can write like this. Draw QM perpendicular to OP produced. Here angle QPM is equal to theta. So to find out this the magnitude of the resultant, we do Pythagoras theorem here. In right triangle OMQ, in right triangle OMQ, by Pythagoras theorem, OQ square is equal to OM square plus QM square. OQ square will give you the resultant R square. OM, you can see here, OM is the sum of OP plus PM, OP plus PM, the whole square. This is square. And QM square. This QM, what is QM? If you use your trigonometry here, this is perpendicular, this is hypotenuse. Perpendicular hypotenuse is sine, so it will be B sine theta. It will be B sine theta. And PM here is, this is base, this is hypotenuse, so it will be B cos theta. If we apply trigonometry in that region. So now QM square, I'll write B sine theta, but this is under square. Here, remember that we are finding out a magnitude. Don't put these vectors here. OP is A plus PM is B cos theta square plus B sine, both will be square, B square sine square theta. There is A plus B square, A plus B the whole square. So you write A square plus B square cos square theta plus 2AB is B cos theta plus this last term is B square sine square theta. So this one A square plus, if you look here, this term and this term, B square is common. Cos square theta plus, here you have sine square theta plus 2AB cos theta. So it will become a square plus b square. This term you can see it is one trigonometric identity. Sin square theta plus cos square theta is 1 plus 2ab cos theta. So like this you can find out the magnitude of the resultant. Square, if you remove it, then here 1 square root will come 2ab cos theta. This will give you the magnitude of r. So this is your like formula you have to remember whenever you do numericals. The magnitude of the resultant is given by root over a square plus b square plus 2ab cos theta. Now some special cases will come here. Let us see case 1. If theta is 0 degree, if suppose theta is 0 degree, that means both the vectors are pointing in the same direction. They are collinear vectors. Then in that case cos 0 degree is equal to 1. So your resultant will become, then cos 0 degree is equal to 1. So the magnitude of the resultant r will be root over a square plus b square plus 2ab. Cos 0 degree is equal to 1. So it will be a plus b whole square formula. It will come out. And square and root, if you cancel it, it will be a plus b. This is the first case. So it will be the sum of the two vectors a and b if they are pointing in the same direction. Then case 2, if theta is equal to 90 degrees, say theta is 90 degrees, then cos 90 degrees is equal to 0. And in that case the resultant will be a square plus b square. Cos will not arise, so it will remain like this, root over a square plus b square. And if case 3, if theta is equal to 180 degree, then cos 180 degree is equal to minus 1. So in that case r will be root over a square plus b square plus 2ab into minus 1. Cos 180 degree is minus 1. So you will get like this, a square plus b square minus 2ab. So it will become root a minus b whole square. Square and root, if you cancel it, it will be a minus b. You will get minimum value. Minimum resultant you will get if they are 180 degree with each other. Here you will get maximum value. Maximum value of resultant you will get it. And here intermediate, neither more nor less. Like this, 3 cases you can get it. In this case, what you can understand is the two vectors, they are not in the same order. Theta 180 means one vector is going this side and one vector is pointing on the other side. Both the vectors are facing opposite to each other. Then you will have to subtract the values a minus b. So these are the 3 special cases where you can get the magnitude of the resultant. Now let us see how to find the direction. To find the direction of resultant vector r. To find out the direction, you take this right triangle QOM or QMO. This phi will give us the direction. Direction means at what angle from one vector it is pointing. The resultant is going. Is it 30 degree or 40 degree, 50 degree? That you come to know. That will give you the direction of the resultant vector. So in right triangle QOM or QMO, then phi will give us the direction. you can still remember, I think in chapter 3 we find out the slope. The slope gives us the direction. Here also 10, always you use 10 for getting the direction. 10 is defined as perpendicular by base, that is QM by OM. QM by OM. QM is B sine theta divided by OM is A plus B cos theta. A plus B cos theta. So this will give you the direction, or in other words we can say phi is equal to tan inverse of 10. If you bring this side it will become inverse B sine theta divided by A plus B cos theta. This will give you the direction of the resultant vector R. Now let us see law of sine and cosine. Law of sine and cosine. Law of cosine we have already derived. The magnitude of the resultant vector R is equal to, if vectors are A and B, it is A plus B plus 2AB cos theta under root. This law is known as law of cosine. Called law of cosine in terms of cos. Now what we are going to learn is law of sine. I will take our earlier diagram. O, we wrote P here. This vector is Q, PQ. This one we represented with A. This one we represented with B. And this is the closing side taken in the opposite order. This is our resultant R. It is A plus B. Geometrically it is A plus B. To derive law of cosine, like the earlier one, you can drop it here perpendicular, extend it. Then here we'll write, suppose M, this 90-degree angle in the vector is theta. These two places you will take opposite of angle A, let us take it as alpha, and this one you take it as beta. And then here you have to drop one perpendicular, let it be PN. Perpendicular to OQ. So these are the things that we'll have to do while deriving the law of sine. You can look here carefully. These two angles I have taken. It is your wish. Here alpha, here beta, or here beta, here alpha. Any letter you can use. But you should write down some angles here. And then this one perpendicular will have to draw from P to OQ. Then we'll get the law of sine. Law of sine, what it is, then you can look here and understand. Suppose this is your triangle ABC. Opposite of BC, suppose this angle A, then this is opposite of BC. So it is BC divided by sine of angle A is equal to opposite of side AC. The angle is B. So it will be AC divided by sine B is equal to this side AB. Opposite angle is angle C. So AB divided by sine C. This is known as law of cosine that you are going to find out now. Here you see this is vector A. A divided by sine alpha is equal to beta divided by, or B divided by sine beta is equal to R divided by this angle. This angle in the triangle, this angle will be theta. Overall it is 180. 180 minus theta is equal to theta again. This value also we take it as theta. So let us do and see. To find the law of sine, you will take like this. In right triangle QMP, QM is equal to, this is perpendicular, this is hypotenuse. So QM will be B sine theta. QM is equal to B sine theta. Equation number 1 you can take it. Then in right triangle QMO, QM is equal to R sine beta. This is the hypotenuse, this is the perpendicular, and this is the angle. So QM is equal to R sine theta. Equation number 2 we can make it. Then from equation 1 and 2, you will get left hand sides are equal, so right hand sides also will be equal. B sine theta divided is equal to R sine theta. R sine QMO, the angle is beta. This is beta. So you can write this as B by sine beta cross multiply, this one bring down, is equal to R by sine theta. Mark this is equation number 3. In the same way, taking PN as the perpendicular, you have two right triangles, towards your right, towards your left. So you will take it like this. In right triangle P and Q, this one I am taking right side. So Pn will be B sine alpha. Pn is equal to B sine alpha. This one make it as equation number 4. And in right triangle PNO, this one, Pn is equal to A sine beta. Pn is equal to A sine beta. Make it equation number 5. Then from equation 4 and 5, you will get B sine alpha is equal to A sine beta. This one you can write it as A by sine alpha is equal to B by sine beta. So you can make it as equation number 6. Now you look here, A by sine beta is common here. Both are equal to, one is A by sine alpha and one is equal to R by sine theta. So all the three are equal. We can make it like this, combining equations 3 and 6. We can write like this: A by sine alpha is equal to B by sine beta is equal to, B by sine beta is equal to R by sine theta, R by sine theta. This is known as law of sine. And sometimes this is popularly known as Leibniz theorem as well. This way you can get the law of sine. Look carefully here. This is 180 minus theta. The total angle is theta 180 here. So if you take the coordinate system, add sugar to coffee, here all positive, sine positive, tan positive, cos positive. This is 90 degree. 90 degree, 180 degree, minus theta means here, back you have to go, plus theta then you have to come here. So your value is here sine 180 minus theta. Sine 180 minus theta will be, as it is here sine positive, so here the value will be theta, sine theta. So whether you take here or here doesn't make any difference. This trigonometrically you can get this value as sine theta. Now let us see resolution of vectors. Resolution of vectors refers to splitting of vectors. Suppose a vector is given to you. Suppose this is vector A. This vector splitting up into its component vectors in rectangular Cartesian coordinate. What we do at this point, we try to draw an angle of 90 degree. One line will take along x-axis, one line will take along y-axis. Then if you drop a perpendicular here, and this length will be written as ax, that means value of a along x-axis. And unit vector, we know that along x-axis we take it as I cap, and towards y-axis we write it as ay j cap. So here the angle must be 90 degree. So this vector A has been split up into two components, one along x-axis and one along y-axis. So splitting a single vector into its component vectors, we call it as resolution of vectors. Here the value of ax is equal to a, here this angle along with x-axis we take it as theta, this is base, this is hypotenuse, so base and hypotenuse is cos, so it is cos theta. Ax here is a cos theta, and ay value here is a, this is, if this angle is theta, then this angle will be theta. So this is the opposite side and this is the hypotenuse. So opposite by hypotenuse, or we say perpendicular by hypotenuse as sine theta. Sine theta. Now, what is the resultant value of vector A? Then you can find like this: resultant of vector A is one by one. If you find it will be better. Magnitude of resultant vector A. Magnitude, if I write magnitude of vector A is equal to root over ax square plus ay square. You can remember, I think, your formula. R resultant is root over a square plus b square plus 2ab cos theta. So now here a and b are ax and ay. Is ax and ay. Angle between them is 90 degree. So here cos 90 degree is equal to 0. So this one does not exist. This term does not exist. So r is equal to root over a square plus b square. This will give you your magnitude of the resultant. And direction, if it is asked, here you can find out tan theta. Tan theta will give you the direction. I'll write down here direction. Direction of A is tan theta is equal to ay by ax, it is prefix, like small letter, ay by ax. Why? Because tan theta is perpendicular by base. Perpendicular is ayj. If this is ayj cap, then here also it will be ayj cap. Perpendicular by base gives us the direction. So theta is equal to tan inverse of ay by ax. This will give you the direction, and this will give you the magnitude of the resultant vector A. That is in rectangular Cartesian coordinate. It is in two dimensions. This is your x-axis and this is your y-axis. But in general, in physics, what you do is, the moment you get a vector, if you have to split up, then these are the ways that you can follow. You know that only four coordinates, first four quadrants are there in our coordinate axis. So if you get a vector like this, suppose this velocity vector v, one vector is like this, suppose the velocity vector force. Then other vector is like this, suppose a velocity vector, whatever it will be, m, suppose this is the velocity vector. And then one is like this, suppose. Let the vector be k. Then what we'll have to do is the tail of the vector you select it and you draw two coordinate axes perpendicular to each other. This angle mark it as theta. Then this will become the base. Towards the base it will be v cos theta. This will be v cos theta. And this will be the opposite of that cos theta, and here it will be sin theta, it will be v sin theta. So this way you are going to resolve in general. Suppose this one, this is the tail of the vector. The starting of the vector is called the tail. This is 90 degree to make, like this you have to make it. Then this angle will be 90 degree. This will mark it as theta. Towards theta it will be f cos theta. And towards y-axis will be f sin theta. So like this you can resolve the vector f. The same way here, if you draw 90 degree, like this, two axes if you draw 90 degree here, this angle mark it as theta. Towards theta it will be cos m cos theta, and this side will be m sin theta. This way you are going to resolve in physics afterwards, later on in higher classes. Here also 90 degree, if you make it this way, it will come in fourth quadrant. This is the angle theta, so this will be k cos theta, and this will be k sin theta. So this way, if you know, then this resolution of vectors, you can think that you know everything, because these are the only four ways that you are going to do in the later part in your higher studies. So there are four quadrants in our coordinate axis, so there are four possibilities you can see on the board clearly. And only remember that which side you take angle, the theta, that side will be cos, the other side will be sin. Which side you take angle? If I take the angle this side, then this will be f cos theta, and this will become f sin theta. It's clear, I think. Now let us see resolution of vectors. This is two-dimensional. Let us do it in vector space vector. That is in 3 dimension, and check it how it will look. In this case, if you take this is x-axis, this is y-axis, and this is z-axis, then you locate one point P, and the vector from the origin, we call it as position vector, the vector will be represented by A. Then in this case what you do, along x-axis we'll take it as AX, and angle with x-axis, let us take it as alpha. This position vector along y-axis we take it as beta, and position vector along z-axis we take it as gamma. Then the vectors along x-axis, if it is AX, along z-axis it will be AZ, J cap, it will be I cap, and along y-axis the vector will take it as AY, J cap, and z-axis we take it as K cap. Now in this case you can draw this way, the cube will come in this way, here it will look like this. This way it will look. In this case, the value of AX will be AX. A is your overall vector. This is vector A. So AX will be AX I cap, or we write it as A cos alpha. AY, it will be A cos beta. This is the angle beta, AY cos beta. And AZ, or if I write Z like this, capital letter, then to look as A cos gamma. And vector A we have resolved as ax I cap plus ay j cap plus az k cap. So if you write down the resultant, the magnitude of the resultant vector A is, A will write, that is root over ax square plus ay square plus az square. It will look like this. Z, if you want to write the small letter, it's up to you. Here also in that case write this small letter. This will give you your magnitude and direction of the vector along x-axis. If you want to find, then you have to take this one. Cos ax is equal to a cos alpha. So cos alpha is equal to ax divided by a. Ax divided by, what is a? Magnitude of vector A, that is root over ax square plus ay square plus az square. The same way, if you want to find the direction of this vector A with respect to y-axis, then cos beta, you can take it this one, cos beta also will look like this, ay divided by a, that is ay divided by root over ax square plus ay square plus az square. And similarly, if you want to know the direction of the vector along z-axis, then cos gamma will be az divided by a. Az divided by a is root over ax square plus ay square plus az square. This way you can find out the direction. This tree will give you the direction of vector A, and this will give us the magnitude of A, vector A. So in space vector, in space, if the particle is in space, then this is the way that we have to draw, and this way we have to get the results. Now let us see addition of vector, the subtraction of vectors analytically. Here in this case, ax I cap will be pointing up to this point. Now let us see subtraction of vectors analytically. When we do subtraction of vectors, before you know that vector A, suppose this is vector B, then the resultant we used to draw here to get A plus B. But to subtract it, you have to extend this vector in the opposite direction, then you get vector B. And the angle between the vector, we know that here we take this theta. So in this case, vector minus B is pointing this direction. The angle between them, we'll take it as this is going this way, this is coming like this. So here it will be total is 180 minus theta, or pi minus theta also we say. Pi value is 180 degree. This is the angle between these two. So resultant, you will get it in the opposite order, R, that is equal to A minus B. So analytically when you do resultant vector R, magnitude of R is equal to here A minus B. This is the in vector form. Magnitude of vector R is equal to our previous formula. We know that it's A square plus B square plus 2ab cos, here it is pi minus theta. So ultimately what will become is, it will be a square plus b square plus 2ab cos 180 minus theta is minus cos theta. So the value will be a square plus b square minus 2ab cos theta. This will be your magnitude of the resulting vector r. Then the special cases, number 1, when theta is equal to, this is cos theta, this is theta. When theta is equal to 0 degree, then cos 0 degree is equal to 1. Therefore, your resultant will be a square plus b square minus, this is 1ab minus 2ab. Ultimately, you will get a minus b the whole square. This will be a minus b. This is your minimum value you will get when a and b are at an angle 0 degree. When both of them, suppose a is going this side, b is coming this side, overlapping in the opposite direction, the resultant value will become a minus b. And when theta is equal to 90 degree, case 2, when theta is equal to 90 degree, cos 90 degree is equal to 0. Therefore, the magnitude of the resultant r will be a square plus b square minus 2ab into 0 will give you root over a square plus b square. This is 0. And case 3, when theta is equal to 180 degree, cos 180 degree is equal to minus 1. Therefore, the resultant r will be a square plus b square minus 2ab into minus 1. You will get a square plus b square, minus into minus will be plus 2ab. So you will get here a plus b whole square root over a plus b whole square will become a plus b. So you will get a maximum value. It's just the opposite of addition of vectors analytically. There theta 180, then you get minimum value. Theta 0 degree, then you get maximum value. Here it will be reverse, and this will be the intermediate value if 90 degree there, 90 degree to each other, to the both the vectors. In this case, theta equal to 180 degree means one vector pointing this side and one vector pointing this side. Then you will get a maximum value. Then both will be in the same direction. You will have to add them together, a plus b. With this, we will come to an end to this video. Stay tuned with LFI Educates. Thank you and have a nice day.